We think of SQL as this amazing tool for asking our data questions. Hey, show me all the users from California, or what was our total revenue last quarter? And for that, it's absolutely fantastic. But what happens when you need to go beyond just asking questions? Right? And that's really the heart of the issue. Standard SQL is descriptive. You tell it what you want. But to handle these complex, multi-step operations, you need it to be prescriptive. You need to tell it how to do something. And that, my friends, is where things start to get really interesting. So that brings us to what's kind of been SQL's big problem for a long time. While it's an absolute master of querying data, historically, it just didn't have the tools you'd find in a general-purpose programming language. Just think about it for a second. What if every single time a new student enrolls in a course, you need to check the class capacity, then update the course roster, and then log that enrollment in a separate audit table? Trying to manage all that with simple insert statements, well, it gets messy, and it gets messy fast. You need more power right there inside the database. And hey, guess what? That's exactly what modern SQL gives us. The first major power-up comes in the form of functions and procedures, which basically give SQL its very own programming toolkit. The whole idea here is simple. Reusability. Why write the same complex logic over and over again? Instead, you package it up into a neat block of code. This was officially added way back in the SQL 1999 standard, and it lets you store and run these complex operations right on the database server itself. So what's the difference between them? Well, think of a function like a parameterized view. It always gives you back a single value, and you can use it right inside another SQL statement, like a select query. A procedure, on the other hand, is more like a callable subroutine. You have to use a call statement to run it, and it can perform a whole series of actions and even hand back multiple values through its parameters. And it doesn't stop there, not by a long shot. The SQL toolkit today is packed with all the stuff you'd expect from a language like Python or Java. We're talking while loops, if-then-else statements for your conditional logic, and even some pretty robust exception handling. Okay, but what if even that isn't enough power for you? For the really complex, super specialized tasks, like say analyzing image data or doing some intense geometric calculations, you can use what are called external language routines. This is wild. It lets you write a function in a heavyweight language like C or Java and then call it directly from your SQL code. But, and this is a huge but, all that power comes at a price. It's a massive trade-off. The benefits? They're obvious, incredible power and efficiency. But the drawbacks are serious. You're literally running external code inside your database's memory space. This opens up huge potential security holes. And if that code has a bug, you could corrupt your entire database. It's the classic battle, power versus safety. Okay, so we've given the database a brain. We've taught it how to follow complex, programmable orders. Now let's get to the really cool part, making the database act on its own. Welcome, everyone, to the world of the database trigger. This is the key question, isn't it? We don't want to have to manually call a procedure every single time something happens. That's a pain. We want the database to have, reflexes, to react automatically when certain things happen. And that is exactly what a trigger is. It's basically a stored procedure that you never call yourself. Instead, the database automatically fires it whenever a specific event, like an insert or an update, happens on a table you're watching. It's a database's own built-in automation system. Let's walk through a quick example so this makes sense. Imagine a student's grade gets changed in a table called takes. That's our event. An after update trigger that's been watching that table immediately fires. Then, the action inside that trigger automatically recalculates and updates the student's total credits over in the main student table. Nobody had to do anything. It all just happened automatically. Now, timing is everything with triggers. You've got two main flavors, before and after. A before trigger, as you'd guess, runs before the data change is actually saved. This is perfect for validating data, like checking if the new salary value is within a reasonable range. An after trigger runs after the change is complete, which is ideal for stuff like logging the change to an audit table, or, like in our last example, updating other related tables. Okay, so this all sounds pretty incredible, doesn't it? A super smart, totally automated database. What could possibly go wrong? Well, this is where our story takes a bit of a dark turn. With all this power comes some pretty significant and often hidden risks. One of the sources we looked at for this explainer just nails it with this quote. It's catchy because it's also kind of terrifyingly true.
Once a team figures out how easy it is to just add a little bit of logic here or a tiny bit of automation there with a trigger, it can spiral out of control really, really fast.
And here is the real problem, the absolute heart of the danger. All this logic is hidden. It's invisible. A developer can write a totally normal, simple update statement and have no earthly idea that they're setting off this complex chain reaction of triggers behind the scenes. So when things break, debugging is an absolute nightmare because the problem isn't in the code you can see, it's buried deep inside the database. And this danger just explodes in a few specific scenarios. When you just have way too many triggers. When the code inside them gets super complex. Or, and this is the big one, when one trigger causes another trigger to fire, creating these wild, unpredictable cascading effects. It gets even worse when they start making calls across different servers or contain complex functions. This is how you build a fragile, unpredictable system just waiting to fall over. So, okay, deep breaths. How do we stop this from happening? How do we use all this cool stuff without building a ticking time bomb for ourselves? Well, the answer really comes down to discipline and having some clear guidelines.
It all comes down to one simple rule, a guiding principle for using triggers safely. They should do one small, simple thing. Keep them short, keep them simple, and keep them independent.
So what does that look like in the real world? What are the good uses for triggers? Well, they're fantastic for logging changes to a history table, or for auditing who touched some sensitive data, or even just for automatically stamping a row with a username and a timestamp. You see the pattern here, right? These are all simple, self-contained little tasks. And that brings us to what is probably the most important thing you should take away from all this. Your database is for managing your data. Your application is for managing your complex business logic. The minute you start hiding your core business rules inside triggers, you are setting a trap for your future self. Keep that logic where it belongs, in your application code, where everyone can see it, test it, and maintain it.
So, at the end of the day, these advanced SQL features, functions, procedures, triggers, they're like a superpower. They can do amazing things for you, but they absolutely demand respect. The real challenge isn't just knowing how to use them, it's having the wisdom and the discipline to know when to hold back.